Yo, what is up YouTube? Let's try and tackle this differential equation using the integration factor method. So first thing that we're going to want to try and do is get it into standard form. That's always step one in this kind of a differential equation. And by standard form I mean dy dx or y prime is all by itself. And then we have like a function p of x in front of y and a function q of x on the right, which is all in terms of x. So we're going to start off by dividing by x all the way through, and that gets y prime by itself, and then we get 5 over xy, and we get 2e to the negative 2x over x to the fourth, and we can write that in the numerator as x to the negative fourth. And yeah, let's go ahead and look at what we're going to do from here. First thing we want to identify now is function p of x, which is all the things in front of y. And so there's a little bit more theory behind the integration factor method, but I'm just showing you like the practical method to solve these kind of differential equations. So once we identify p of x, we go and look for q of x, which is all the stuff on the right hand side of the equation. That would be the 2e to the negative 2x, x to the negative fourth. And once we have these two things identified, we make a special constant mu such that it is e to the integral of p of x dx. And this term is going to help us simplify this differential equation. I know I said this wrong, I said integral. We're simplifying this differential equation into something where we could just integrate both sides and get y by itself. So like I said, mu is equal to the integral of p of x dx. In our case, that would be the integral of 5 over x dx, and that's the natural log of x to the fifth. I did skip a step there. It's 5 natural log of x and then I just moved up the x. And then right here, when you integrate, you would have a plus c, but in our case, we're going to ignore that for now, and we're also going to drop the absolute value bars. And like I said, there's more theory to this, but this is just the method. So once we have mu, we're going to multiply it, and then we get this clever thing where it's a chain rule, and we can simplify it to just be d over dx equals mu y is equal to q of x times mu. And then like now you can kind of see the equation. We could integrate both sides and get just mu y equals the integral of q of x mu. So let's go ahead and lay this out for our problem. Mu is x to the fifth, so we have the derivative of x to the fifth y equals 2e to the negative 2x, x to the negative fourth, x to the fifth, and then we simplify those x's. And now we're going to be integrating on both sides. So I'll show you what that sort of looks like in just a second here. I'm just rewriting this in terms of the simplified expression. And now, yeah, integrate both sides. And when we integrate 2x e to the negative 2x, it's a tabular method. And when we integrate the left side, we use the fundamental theorem of calculus to say the integral with respect to x of the derivative with respect to x is simply that thing. So here's the tabular method. If you're not familiar with this, I have a couple of videos on my channel and you could check those out. But you lay it out. It's like doing integration by parts shorthand. And I'm kind of zooming in here so you can see what I'm doing. On the right hand column, I'm taking integrals or antiderivatives. And on the left hand column, I'm doing derivatives. I chose the polynomial term on the left column and the e to the negative 2x term on the right column. And then you do plus 2x times negative 1/2 e to the 2x. So it's 2x over 2, and it's negative because of the negative 1/2 e to the x, and those two cancel, and we get x e to the negative 2x, negative x e to the negative 2x, and then over here we have the fourth. And don't forget your plus c when you're doing integration by tabular method. And now we have that x to the fifth y is equal to negative xe to the negative 2x minus 1/2 e to the negative 2x plus c. And at this point, we can just divide the whole equation through by x to the fifth, and I'll show that on the next slide. I'll go ahead and copy all this over in just a second. Put that in there, size it up a little bit for you, and then when we're dividing by x to the fifth, we get y by itself equals negative x e to the negative 2x over x to the fifth minus e to the negative 2x over 2x to the fifth plus c over x to the fifth. And from here, we do a little simplifying magic, cross out like terms in the denominator and numerator and stuff like that, and then we write out our final answer to be negative e to the negative 2x over x to the fourth minus e to the negative 2x over 2x to the fifth plus c over x to the fifth. And that's our solution. Thanks for watching, guys.